To finish off chapter 17, starting off with carboxylic acid. They all contain the COOH functional group. To display this functional group out, it's written as this. And these lines represent the bonding electron pairs. And in order for these atoms to be stable, they need to have 8 electrons around it in the outer shell, in the outermost shell. That means for each atom, like oxygen and carbon, they should contain 4 lines around it to have 8 electrons. And these are the non-bonding electron pairs. For this carbon, it's already stable. It has 4 lines around it, 4 bonding electron pairs constituting of 8 electrons. This oxygen, it has 2 lines, 2 bonding electron pairs, and 2 non-bonding electron pairs. For hydrogen, instead of having 4 lines, it should only have 1 line around it because hydrogen only has 1 outermost shell, 1 electron shell, holding up a maximum of 2 electrons. And for all the carboxylic acids, their names end with oic acid. The most important carboxylic acid, for example, is ethanoic acid. From the name, you can tell the number of carbons should be 2, and the functional group contained is carboxylic acid. Let's write down the structural formula of ethanoic acid. We have 2 carbon atoms, and one of which is gonna have your functional group of COOH. The other one is connected to 3 hydrogens. This is the fully displayed formula. If you want to condense it to a condensed form, this is a CH3 group, and this, the characteristic carboxylic acid functional group, is written as a COOH. So the ethanoic acid can be written as CH3COOH. And the molecular formula is C2H1234O2. So this allows us to work out the general formula. The general formula should be CnH2nO2. If we think about the number of hydrogens bonded to carbon atoms, starting with an alkane, for example, an ethane with 2 carbon atoms, can be bonded to 6 hydrogen atoms. The overall general formula is CnH2n plus 2. However, if you switch one of the bond, the CC bond, to a double bond, so from a saturated organic compound to a unsaturated one, the number of hydrogen atoms that can be bonded reduces. It reduces to 4 instead of 6. So the general formula becomes CnH2n, as the number of hydrogen atoms can be bonded has reduced by 2. Similarly, as here we have a CO double bond, although it's not a CC double bond, the number of hydrogen that can be bonded to this carbon has dropped by 2 as well. So that's why the number of hydrogen also follows CnH2n. In addition to this, because we have 2 oxygen atoms in the carboxylic functional group, that's why we have O2 after the CnH2n. That is the general introduction to carboxylic acids. Moving on, let's have a look at some chemical reactions. The first chemical reaction that we're going to look at is a reaction to produce ethanoic acid from ethanol. In our last lesson, we studied the chemistry of alcohol. Ethanol, from the name, it should contain 2 carbon atoms, one of which is bonded to an OH group, and the rest should all be hydrogen atoms. Make sure each carbon is bonded to 4 other groups, and it can be turned into the ethanoic acid that we saw just now. Again, 2 carbon atoms, but this carbon is bonded to a COH group. And this is called the oxidation of ethanol. We have studied the definition of oxidation. In inorganic chemistry, oxidation can be gain of oxygen or loss of electrons. Well, actually, this loss of electrons is the ultimate definition of oxidation. Because of the loss of electrons, the atom becomes more positive than before. And by becoming more positive, the oxidation state will increase. So it can also be the increase of oxidation state. That's what we have learned in inorganic chemistry. In organic chemistry, when we talk about chemistry that involves carbon, then oxidation, the definition of oxidation is wider. Oxidation is defined as the gain of oxygen or the loss of hydrogen. Now, if you look at the molecular formula for alcohol, for this ethanol, it's C2H5OH. For ethanoic acid, it's CH3COOH. We can see an increase in the number of oxygen as well as a decrease in the number of hydrogen, and that fulfills the definition of oxidation in organic chemistry. So this process is oxidation. And how does it happen? Let's move on to the box below. This happens naturally. Bacteria can do this for us. If we leave ethanol in the air, the bacteria can oxidize the ethanol into ethanoic acid. So this is a natural process that happens at room temperature. That's why we call this the biological way. And this is also called fermentation. When we talk about fermentation, that means this process is anaerobic, without oxygen. It takes place without the oxygen gas. And this process can be used to make vinegar, 醋. The main component of vinegar is ethanoic acid. 我们喝的醋里面主要的成分就是乙酸。Okay? So let's quickly think about the biological way that we learned in the last lesson. In the last lesson, we also looked at a natural process that turns glucose into ethanol. This is also called fermentation, as it also takes place without oxygen. But this process turns glucose into ethanol but the process that we looked at just now turns ethanol into ethanoic acid. Moving on to the next box, we can use oxidizing agents. So instead of letting bacteria do the work, we introduce an oxidizing agent to chemically oxidize ethanol into ethanoic acid. So that's the chemical way. And we have studied some common oxidizing agent in the previous chapter. And in this chapter, we're going to introduce the acidified potassium manganate. We use 7 in bracket to represent the oxidation number of manganese. It's KMnO4. And the redox process, if we write down the half equation, the manganate 7 ion, if you're not sure about the oxidation number, we can calculate this. For oxygen, the oxidation number is -2, and the oxidation state of manganese has to be +7 to make an overall of minus charge. And this ion has a purple color. By gaining electron, it will be oxidized to manganese 2 ion, which is colorless. This equation is quite difficult to balance, but we can do it step by step. If you want to balance a complicated half equation like this, firstly, you need to work out the number of electrons transferred. So from +7, having 7 positive charges, to having only 2 positive charges, each manganese should have gained 5 electrons to move from +7 to +2. But we have another problem. The charge is not balanced. Here on the left-hand side, you have 6 negative charges. On the right-hand side, you have 2 positive charges. How do you balance the charge? Note that this oxidizing agent only works in the acidified environment. That means you have lots of hydrogen ions around. Remember, for an acid, it is a hydrogen ion donor or proton donor. A hydrogen ion is essentially a proton. So with an acid around, there should be lots of protons, lots of hydrogen ions around. So the next step, you can use the hydrogen ions to balance the charge. So to balance the charge, I need to put 8 hydrogen ions on the left-hand side. So on each side of the chemical equation, I have 2 positive charges. However, we haven't balanced the number of hydrogen and oxygen atoms on either side. So lastly, you can see this oxidizing agent works in a solution. There must be lots of water molecules around. So lastly, you use water molecule to balance hydrogen and oxygen. So how many hydrogen and oxygens do we need? We need 8 hydrogen atoms and 4 oxygen atoms. So you can simply put 4 H2O on the right-hand side to balance the number of hydrogen and oxygen, and this equation is balanced. So how can you tell there's an redox reaction happening? So if I have a test tube with acidified potassium manganate solution and your alcohol, you will see potassium manganate is able to turn alcohol into ethanoic acid. And because it's acting as an oxidizing agent, it will become manganese ion, manganese 2 ion. So this is followed by a color change. When you see potassium manganate around, it should be purple. But when your oxidizing agent is used up, or your oxidizing agent has been reduced to manganese 2 ion, this should be colorless. Right, so here we have seen two reactions that oxidizes ethanol into ethanoic acid. One is the natural way, done by bacteria, and the other one is the chemical way. We introduce an oxidizing agent that oxidizes ethanol into ethanoic acid. Moving on, let's have a look at some reactions of carboxylic acid. By acting as an acid, it should be a proton donor or hydrogen ion donor. So how does it donate the hydrogen? Let's write down the structural formula of an ethanoic acid. Which of these hydrogens can be donated? The answer is this hydrogen. By giving up the hydrogen over here, the ethanoic acid will have lost this hydrogen as a proton, and the rest will become a negatively charged ion called ethanoate ion. And this is the hydrogen ion. And this is our ethanoic acid. Now, think about why it is a weak acid. What is the difference between a weak acid and a strong acid? You may pause the video to think about this question. Now let's have a look at the definition of an acid again. The strength of the acid is measured by the ability to give away the proton. If we have a strong acid, like HCl, it's willing to give away the hydrogen ion. In other words, it's not a reversible reaction. Once the hydrogen ion has been given off, it does not combine with the anion. They don't form the HCl backwards. It's very happy to give away this hydrogen ion. It's a strong proton donor. However, if you look at this weak acid, it's very unwilling to give away this hydrogen ion. Only if I have 100 ethanoic acid, probably only one ethanoic acid gives away this hydrogen. Most of the other ethanoic acid would hold on to this hydrogen ion. As you can see, the hydrogen ion may stick back to the anion and form the ethanoic acid. The dissociation is incomplete. It's unwilling to give away the hydrogen ion as an acid. That's why it's called a weak acid. Now let's write down this equation in the form of condensed structural formula. The condensed structural formula for ethanoic acid is CH3COOH. And for ethanoate ion, it is CH3COO minus. That's the condensed form. You can also add in the state symbol. Right, so let's have a look at the common reactions of acid. For an acid, it reacts with a base to form salt and water. And the ionic equation is basically a hydrogen ion reacting with a hydroxide ion forming water. Let's look at a chemical reaction taking place between ethanoic acid and sodium hydroxide. Here's our acid, and here's our base, the alkali. Remember the definition of a base as a proton or hydrogen ion acceptor, which is the opposite of an acid. A base can receive a hydrogen ion. So after the reaction, we can see the formation of a water molecule, as this hydrogen ion has combined with the OH minus ion, forming water molecule. So how do we put the rest together? So as you can see, if we ignore the hydrogen ion, the rest will be an ethanoic ion, carrying a negative charge. This would be negative. And if we ignore the hydroxide ion, the rest will be sodium ion. But when you put these two together, you don't necessarily need to show the charges. You can leave the charge there, or you can just erase them away. So that's your salt. A salt contains a positive ion and a negative ion. And here's your positive ion, here's your negative ion. And this salt has a name called sodium ethanoate. Just like any ionic compound, the name starts with the cation and it's followed by the anion. And the charge ratio is a 1-to-1 ratio. So that's the neutralization reaction. You can also write it in a condensed form. The condensed form for ethanoic acid is this, plus NaOH, giving a water molecule, and CH3COONA. That's the sodium ethanoate. Reaction number 2 is esterification. This is a completely new reaction that we haven't learned. In this reaction, it involves a ethanol and a acid. So let's still use ethanoic acid as an example. And the alcohol that I'm going to use is propanol with 3 carbons. Okay. For your simplicity, I'm gonna put my OH group here. Sorry, I'm gonna put the OH group here for simplicity. Okay, So when these two molecules are placed in a concentrated sulfuric acid, there will be an esterification reaction. The hydrogen over here will react with this OH group over here, and they will be combined together. And that's going to form a water molecule. And the rest will be connected to each other. So you just need to copy down the left-hand side. And instead of being bonded to this OH group, as it is lost, it will be connected to this oxygen, as this hydrogen is lost. And the rest, just copy down. And this is the product. And in this product, we can see a new functional group that we haven't seen before. And this functional group is called an ester group. I'm going to use a different color to label the ester group. Sometimes we use ester linkage to refer to this functional group because it always links one group with another. How do we name this ester though? When we name an ester, we start with the alcohol bit. So this is called, instead of being called a propanol, it's called a propyl. And then we name the rest. Then we name this bit. This bit comes from your acid, and the name is called ethanoate, and you should be familiar with it, as we saw ethanoate over here and over here. And the name of this ester is called propyl ethanoate. We'll look at the naming in more details down below. Now let's fill in the handout. Because as two molecules join together to form a really big molecule, one small molecule is lost. This is called a condensation reaction. And this reaction is reversible. It can go backwards to the two starting products. The sulfuric acid over here is acting as a catalyst. Right. Now let's have a look at the naming of esters. As you can see, this group ends with YL, and such groups are called alkyl groups. They all end with YL. Let's have a look at some alkyl group. The one we saw in the previous example is propyl, and it has 3 carbon atoms and it's bonded to something else. In this example, it is bonded to an ethanoate group, and the rest are all hydrogens. We can also abbreviate this to a CH3, CH2, CH2, and a bond. This is a propyl group, as it contains 3 carbons. So think about the name of this group, a CH3 group. It ends with YL and it only contains one carbon. The name is methyl. Methyl. If it's two carbons, then we have CH3 and a CH2 and bonded to something else. It is an ethyl group. An ethyl group. So these groups come from alcohols. So when you see an alcohol, for example, a propanol, during the esterification process, this would be, all you can see in the ester is the part without the OH. So that would be a propyl group. And then you will see a group that comes from the carboxylic acid. And the carboxylate group end with noate. For example, ethanoate. So let's have a look at some examples. In the previous example, we saw ethanoate. If I increase the carbon number by 1, what should be the name of this group? It should be a propanoate. And these groups come from the carboxylic acid. With one more hydrogen, it will be a carboxylic acid. And this group is named next. So name the alkyl group first and the carboxylate group next. Now you can try some exercises. Exercise 1 is naming the esters.